Hi students, this is Miss Waldorf here, and today we are going to learn all about triangles and their sides. Now, a lot of you guys are probably thinking, well, 3 sides form a triangle. And you're right, but there's a specific rule with the size of each one of those side lengths if we want to actually form a complete shape. And we're going to dive into that now. Now, our rule with whether or not a particular 3 sides actually makes a triangle is that the sum of the lengths of any 2 sides of a triangle is greater than the length of the 3rd side. So, therefore, the sum of the 2 shortest sides must be greater than the longest side. This is our rule, that the sum of the 2 shortest sides must be greater than the longest side in order to form a triangle. So, starting with this one that actually is a triangle. We have side lengths of 4, 5, and 7. If we follow our rule, the sum of the 2 shortest sides must be greater than the longest side. So our 2 shortest sides here are 4 and 5. The sum of those 2 numbers is 9. And is 9 greater than the longest side of the triangle of 7? Yes. And that's exactly why we're able to complete a full triangle here. We have our longest side of 7. 9 units will certainly cover 7 units. Now on to the next shape, which failed to make a triangle. We have our 2 shortest sides, which were 4 and 2. The sum of those 2 numbers is 6. Is 6 greater than 7? No, okay? And that makes perfect sense as to why we weren't able to make a triangle, because you cannot cover 7 units with only 6 units. It won't be complete, and that's exactly why we have a gaping hole in what would have been a triangle. So, our rule to determine if 3 side lengths form a triangle is that the sum of the 2 shortest sides must always be greater than the longest side. So, let's explore some lengths. We have 3 side lengths given to us 4 different times, and we need to determine when 3 of these side lengths will actually form a triangle. So I'm going to follow my rule that the sum of the 2 shortest sides must be greater than the longest side. And I'm going to test this out below. So first I need to identify the 2 shortest sides when I have 11 centimeters, 2 centimeters, and 12 centimeters. And my 2 shortest sides are going to be 2 centimeters and 11 centimeters. Now, I'm going to lay this out to model my rule. The sum of the 2 shortest sides, which would be 11 and 2, need to be greater than the longest side of 12. Well, 11 and 2 add together to give me 13. Is 13 greater than 12? Yes. So we can say, yes, it's a triangle. Perfect. Now on to my next 3 side lengths. We have 7 feet, 5 feet, and 12 feet. And we need to see if the sum of the 2 shortest sides is greater than the longest side. So my 2 shortest sides are 7 and 5 here. I will add those together and then see if those actually end up being greater than the longest side of 12. Well, 7 and 5 together give me 12. Is 12 greater than 12? No, they're equal. Therefore, we would state no, this is not a triangle. It's not going to be a triangle because the sum of the 2 smallest sides was not greater than the largest side. On to the next one. We have side lengths of 11, 1, and 9. I'm locating my 2 smallest side lengths, which would be 1 and 9. So I'm going to write out my inequality. 1 and 9 need to be greater than 11. 1 and 9 together give me 10. Is 10 greater than 11? Nope. Therefore, we say no, not a triangle today. On to the next one. We have 3 side lengths again, and we need to first locate the 2 smallest ones. We have 12.5, 13.25, and 2. And I see that my 2 smallest side lengths are going to be 12.5 and 2. So 12.5 plus 2 needs to be greater than 13.25. When I add 12.5 and 2 together, I get 14.5. Is 14.5 greater than 13.25? Yes. So we say yes, it's a triangle. If you have any more questions about whether or not 3 side lengths form a triangle, feel free to attend our office hours, message us on It's Learning, or email us. All of your teachers are here to help you. Thank you so much. Have a great day.